right, we should be completely done with page 1. And you have all that ready, so when we need it, we have the density of water. Very, very accurately to 4 sig figs. Okay? And now I would like you to, again, some of you have probably already copied this. If not, read and copy data table 2. We're going to be adding some data to that table. So go ahead and hit the pause and come back when you're ready to record data with us. All right, welcome back. So the first thing it said is take a 100 milliliter beaker. It's one of our kind of smaller beakers. And just to make sure that it was clean and dry, just take these little paper towels and sort of wipe it off on the outside. You want to get any little air out of this lab that we can. So now we got a nice, clean, dry beaker as specified. Scale is at 0, and we're weighing the beaker. 50.35 grams, so it's 50.35 grams. And you're going to write that in all 3 trials as they say in step 1. So trial 2, 50.35 lowercase g. Trial 3, 50.35 lowercase g. All right, now, polyurethane. What is this? Well, now we're going to get to the goal of the whole thing that we're doing. Kind of hard to see this in too much detail, but what this is this is the piece of the sole of a shoe. One of the things they have to do at Red Wing Shoe as chemists is make darn sure they know what the density of the polyurethane they're making. You can feel that this is it's pretty low density. Definitely would float in water. You can guarantee that. So that'll be a hint for you that this density is going to be less than 1 for sure. Okay, so all we need to do is figure out the density of this. Well, the first part is really easy. You'll notice this has a little pin in there. I'll explain what that is later, but obviously you want to take the pin out. I'll see a lot of groups will do that. They'll weigh the pin too. But we want just the mass of this polyurethane. So put that on there. This polyurethane weighs 23.35 grams. And you're going to write that for all 3 trials. 23.35 grams. So the 0.35 is same above. Interesting. 23.35 grams. Okay, so that part was really easy. Now we have the mass of this piece of polyurethane. Well, what we're going to do now is I'm going to put this pin back in there, and then we're going to do something called collecting and figuring out what the volume is by submerging this in water. Okay, so what we're going to do is we're going to use the same water, same temperature that we used in the first part. Okay, so now I've got this, and you'll see what happens is there's this little valve, and you see the water is pouring out that little valve. So right now it's filled right up to the tippy top of where that valve is. And you got to wait for a little while. You got to be kind of patient. Water is very cohesive. It likes to kind of stick to itself. So right now we try not to bump the table too much and just let that settle and let the last drops naturally come out of there. And that should be pretty good, okay? So then what I'm going to do is I'm going to take this beaker that we weighed, and I'm going to put that underneath, and then I'm going to submerge this entire piece of polyurethane under there. But I'm going to hang on to the pin, and I'm going to wait for the... So basically the volume that came out of here is exactly the same. Wait for those last drops to stop again. So when I submerge that, and I had to push it because remember it's less dense than water. I gave you that clue. So the volume of this water is going to equal the volume of the polyurethane sample. They're the same. This volume and that volume are the same. Well, you know, just looking crudely, I can see, you know, in the neighborhood of 40 milliliters. That's not going to cut it. We need it more accurate than that. Well, that's where page 3 comes on. And by the way, there'll be no video for page 3. That part you have to figure out on your own. Page 3 is we can use the density of the water and the mass of the water to calculate the third quantity, which is volume. So that's why we figured out the density on page 1. And if you want to take a peek ahead to page 3, you see that's all calculations. If you want to find the volume, all you have to do is take the mass of the water, which is pretty easy, because I'm just going to weigh it again, right, and subtract the mass of the beaker. So that is the good news about how we're going to be able to find this, and again, to 4 significant figures. Okay, so we're back to the data table right now. You should have the top 2 lines filled up, and now the mass of the 100 milliliter beaker and water is, drum roll, dun, da, 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 90.32 grams. 90.32 grams. Okay? So now to find the mass of the displaced water, all you got to do is subtract the mass of the beaker. And then you'll have. So that bottom column, I'm leaving up to you. But you better get the same answer I did because you got the same data that I have. Okay? So 90.32 was our first trial. Okay. So I like to just pour that back in there and set this up the same way that we did the first time. Okay, so what we're going to do now is we're going to do the next trial. Okay, so this is going to be trial 2. So for trial 2, get this set up again. Remember, pour it up above the top of the valve like that, and you're just kind of letting that water run out naturally, and then it'll be all set up for trial number 2. All right, so I'll just let that finish dripping out on the table, so you can see it's still dripping a little bit, and you want that to finish up. Just kind of put that little paper towel under there. And I'm going to use the same beaker. That's really important. You can't say, oh, let's just grab another one that's dry. That wouldn't work, because all beakers weigh a little bit different. And this is really, we want really good accuracy. Now, I don't have to weigh it again, because the mass of the beaker is not going to change. And if it does, that would just be error anyway. So I'm just going to polish that guy all up real nice again. Okay, and guess what? We're going to do the same thing again, where hopefully you'll get a good look at this. As soon as I push that through, the water comes out. Okay, and then I just have to hold it down, submerge that, and again, you wait for the dripping to stop. It's dripping pretty rapidly right now. And then I usually just wait for it to kind of slow down to one drop like every 5 seconds, because this is kind of a long wait. And that's good. All right. So, same piece. So you would think we're going to end up with the same results. Okay, so let's see. This is for trial 2, mass of the 100 ml beaker and water. So that third row, middle column, trial 2, is 90.58. 90.58 grams. So you can see there's quite a bit of difference on that. Quite a bit of difference the second time around. Tried to recreate and do it exactly the same way, but it's kind of this second trial is usually way different. Okay, not way different, but you know it's not as accurate or as precise. There's the word, precise, as what we had on the first page. Okay, so we've got one more trial to do. So I will do this same thing. Just let that go up over the top. And then just kind of start dripping out of there. And I'll get rid of that water sample. And dry this off so that you aren't starting with water already in the beaker. Okay, and that's finishing up its dripping right now. 1, 2, 3, 4, 5. Wait about 5 seconds. Good. Okay. All right. So third and final trial. The beaker plus so again, you gotta wait for that dripping to kind of, we're gonna finish just in the nick of time. Okay, so boom. Now we weigh it again. There, weigh. Third and final trial. 90.88 grams, and that's not unusual. And it's you don't ever want to fudge results in a lab. I could have easily done that because you guys can't even see what's on there. But we're just gonna, those are the results, okay? So you can figure out the mass of the water yourself, and page 3, you're on your own. Follow those directions very carefully. Make sure you're doing what they say in each step, and then you can do all of page 3. It's all calculations, and we're going to use that density of the water to figure out the volume of this guy to 4 sig figs, and then we can really rock and roll. So you're done now with pages 2 and 3, and I will do page 4 in a separate video.